Your shortened valley rafter is held up by your supporting valley rafter. Let's take a close look at detail 4C9, your shortened valley rafter at the supporting valley. This is your supporting valley rafter and your shortened valley rafter. Your offset framing point. This is the shortened valley rafter, 3C, and a detailed view here at 1C10. Alright, shortened valley rafter framing point. What we have to do is we have to offset the framing point from the ridge line. Now we talked earlier about the offset run being 3'8". So we want to calculate from the ridge line. We want to determine the mathematical framing point offset length. The mathematical framing point offset length. We know the total run is 3'8", and we know the unit length is 18. So just do the math, and the mathematical length comes out to 5'6". We've gone through that calculation earlier, so it's the same deal. It's from the framing point at the valley to the building line. Mathematical length is 15 feet. We've gone through that before. We've gone through the mathematical overhang length before. Still 3 feet. And there's our worksheet. Rafter 3C is valley rafter. Total run is 10 foot. Unit length is 18, less the offset, which we talked about earlier. That offset is 5'6". Set your framing square to 6 over 16.97. The setback, half the thickness of the supporting valley rafter. Notice this line is indicated in red, so this is where your saw cut takes place. And other than that is basically the same layout as the valley rafter. Here's a 3D view of our project so far, and this is the section we're going to be working in. We've got these rafters basically figured out, so we're going to put them in place now. Here's a reference line here for us to use. It comes off at a 45-degree angle. And here's our framing point at ridge beam A. We talked about the supporting valley rafter layout earlier. That's right here. And we're going to set the supporting valley rafter in place. Starting at the framing point, coming off at a 45-degree angle to the inside corner. And then off of the supporting valley rafter, we'll be setting our shortened valley rafter. So remember we talked about the offset length being 3'8". So you put a marker on that rafter, and from the framing point to the inside corner, we now have the shortened valley rafter. And there's a 3D view of that. Now it's time to set ridge beam C in place. I'll start by taking a section view and establish the height. The span is 12'8". Half of that is the total run, 6'4". Total rise is 3'2". And we're looking at the detail view now of ridge beam C. This is your ridge beam height, and again it's measured above the plate line. And we've been through this before, so it's 3'2", plus the height above plate line, less the loss at the top. making your total height 3 foot 8 and 5/8. Taking a closer look at ridge beam C, we just established the top of the beam height at 3 foot 8 and 5/8. Let's look at the beam length. We'll start with a 10-foot run from the center of ridge beam A to the building line. From the building line to the outside wall of the bump out is 8 feet. So from that 10 feet, we're going to subtract 3 foot 8, which is your offset. And again, that goes from the center of ridge beam A to your offset framing point. We'll take a closer look at that detail. We need to establish the setback. And this is half the ridge thickness times 1.414, equaling a 2 1/2 inch setback. So when you do all of your math, you take the 6 foot 4, you subtract the 2 1/2 inches, you add that to 8 feet, you end up with the 14 1/2, add 2 feet to that, and you come up with a beam length of 16 feet 1 1/2 inches. The cheek cut is 3/4 of an inch, which is half the thickness of the rafter. And taking a closer view here. Remember to notch for the barge rafter. There's your rafter reference layout 5G. And from that point, you do your 2 foot on center rafter layout. And now we'll set ridge beam C in place. You can just hang it out there in the air, so provide some supports. And you can see the intersection here. And this is the top view.